Welcome everybody. My name is Isabella Gazzetto and I'm an Environmental Pollution Advisor at JNCC. This presentation will introduce the Joint Nature Conservation Committee, otherwise known as JNCC, and the Reducing Pollution through Partnership project. We will explain the aim of the local sense check and set out the method used based on information provided by the International Union for Conservation of Nature, otherwise known as IUCN. We will then present the pilot country results specific to Vietnam, where we welcome discussion based on how the results reflect your local knowledge. This video is the third out of a series of 3 videos created to support the delivery of the Reducing Pollution through Partnership project. The first video introduced the methods used in the global analysis, and the second video presented the results of the global analysis. This third video uses the results and zooms in on Vietnam to detail these results specific to your country. JNCC is the public body that advises the UK government and devolved administrations on the United Kingdom and international nature conservation. Our people are dedicated to providing high-quality scientific evidence and advice on the natural environment. The aim of this project is to scope and help design a wider pollution programme to be delivered by the United Kingdom in low and middle income countries. The programme is to enhance the ability of these countries to manage and to reduce air, chemical and waste pollution. Our priority is to engage early with pilot countries to understand how to better deliver a fit-for-purpose pollution programme in the future. JNCC was commissioned by the United Kingdom Department for Environment, Food and Rural Affairs to deliver the project scoping year. The aim of the local sense check is to validate the preliminary results of the global analysis and determine whether this reflects local knowledge in Vietnam. We are looking to find out whether the results are a true representation of how pollution impacts threatened species in your country, and your help is valuable in achieving this. As the basis for this analysis, we use the data from the International Union for the Conservation of Nature Red List of threatened species. This is a list of species assessed for extinction risks using the IUCN Red List categories and a set of criteria. Threatened species are those with an assessed extinction risk as either critically endangered, or vulnerable, and these species have been included in this analysis. We have also included those listed as near threatened, and these are species who are close to the threatened thresholds, or those that would be threatened without ongoing conservation measures. The data can be used to determine what is impacting which species globally, and the information is publicly available on the IUCN webpage, and the databases are available at request. This IUCN Red List assessment also includes the major threats to species, such as the different forms of pollution listed in this slide, as listed under Category 9 of the IUCN Red List Threat Categorization Scheme, and this assessment is what formed the basis of our analysis. A more detailed explanation of the methods and criteria used can be found in the Pilot Country Pollution Analysis Report for Vietnam. From the global analysis, we are able to uncover the percentage of species impacted by pollution in Vietnam, given as a proportion of the total number of threatened species. The pie chart shows that 32% of species are threatened by pollution in Vietnam, with 68% of species impacted by other threats. Other threats, as classified by the IUCN Red List assessment, may include threats such as energy production and mining, biological resource use, geological events, and agriculture and aquaculture. We're interested to hear how these proportions shown relate to what you know about pollution in Vietnam. The global analysis also enables us to identify the percentage of species threatened by pollution that are also impacted by climate change. Of the species threatened by pollution in Vietnam, 72% are also impacted by climate change. This is compared to 28% of species being threatened by pollution but not climate change. As before, we're interested to hear how these proportions shown relate to what you know about pollution in Vietnam. In this table, you see the number of species impacted by pollution in Vietnam. This table groups the number of species into the higher pollution threat categories, but a more detailed results table of the pollution threat breakdown is available in the Pilot Country Pollution Analysis Report for Vietnam. At the top of the table are 298 species impacted by agricultural and forestry effluents, which includes the subcategories of nutrient loads, soil erosion sedimentation, herbicides and pesticides, and unknown unrecorded. The unknown unrecorded category is for cases where the pollution is not specifically captured under the classification scheme, or where the source of pollution may be unknown or from a historical source. Next down the table, and the pollution threat with the second highest number of species impacted, is domestic and urban wastewater, impacting 258 species. This includes the subcategories of sewage, runoff, and unknown unrecorded. At the bottom of the table, we find excess energy, impacting 8 species. Excess energy includes subcategories of noise pollution, light pollution, thermal pollution, and unknown unrecorded. We would like your feedback on whether there is any important information missing to help us understand the sources, types, locations, and impacts of pollutants in your country. Overlaying range maps of any species which is assessed as threatened by pollution can hotspot where multiple species are impacted. All entries only include ranges of species known to occur in an area. This gives us a global picture of the extent of species assessed as threatened by pollution, but we can zoom in on specific countries and explore the breakdown of species and their threats. We are looking to find out whether the information shown on the following pollution heat maps about the distribution of species threatened by each pollution threat type reflects your understanding and experience. It is worth noting that all heat maps and more detailed information about the species can be found in the Pilot Country Pollution Analysis Report. "258 species are affected by the higher category of domestic and urban wastewater in Vietnam, which is made up of the subcategories of sewage and runoff, which I will present in the following 2 slides. This heat map shows the overlapping ranges for species where range data is available. Please see video 1 for reasons data may not be available for all species. The darker areas are where multiple species are impacted. Domestic and urban wastewater is defined by the IUCN Red List as waterborne sewage and non-point runoff from housing in urban areas that includes nutrients, toxic chemicals, and/or sediments. The heat map shows darker hotspotting predominantly along the coastline, suggesting that this threat is impacting mostly coastal and/or marine species. There is also a click hotspot surrounding the area where the Mekong River and other tributaries meet the sea. Sewage is a subcategory of domestic and urban wastewater, affecting 24 species, and this heat map shows the overlapping ranges for those species impacted by sewage in Vietnam, where range data is available. The darker areas are where multiple species are impacted. Examples of sewage is defined by the IUCN Red List include discharge from municipal waste treatment plants, leaking septic systems, untreated sewage, and outhouses. There is hotspotting predominantly along the coastline and in the centre of the country. There is also a hotspot towards the south of Saigon. The table shows that fish and mammals are the classes with the most species impacted, with 5 species in each. This is then followed by amphibians and bivalves, both with 4 species, and at the bottom of the table are sharks and rays, plants and snails, with 1 species in each class impacted by sewage. Runoff is another subcategory of domestic and urban wastewater affecting 8 species, and this heat map shows the overlapping ranges for species where range data is available. The darker areas are where multiple species are impacted. Examples of runoff, as defined by the IUCN Red List, include oil or sediment from roads, fertilizers and pesticides from lawns and golf courses, and road salt. Similarly to the heat map we just saw of sewage, there is hotspot mostly around the coastline, and as before, there is a hotspot south of the city of Saigon. The table shows that fish are the class most impacted by runoff with 4 species, and this is followed by bivalves, sharks and rays, mammals and reptiles, all with 1 species impacted in each. There are 245 species impacted by the higher category of industrial and military effluents in Vietnam, which is made up of the subcategories of oil spills and seepage from mining. This heat map shows the overlapping ranges for species where range data is available. Industrial and military effluents are defined by the IUCN Red List as waterborne pollutants from industrial and military sources, including mining, energy production, and other resource extraction industries that include nutrients, toxic chemicals, and/or sediments. Hotspotting is predominantly seen along the coastline and offshore, suggesting that industrial and military effluents are impacting more coastal and/or marine species. There is also a notable hotspot in the north of the country, in the region north of the cities of Ninh Binh and Hanoi. Oil spills are a subcategory of industrial and military effluents affecting 7 species, and this heat map shows the overlapping ranges for those species impacted by oil spills in Vietnam, where range data is available. The darker areas are where multiple species are impacted. Examples of sources of oil spills as defined by the IUCN Red List include leakage from fuel tanks, oil spills from pipelines, and PCBs in river sediments. There is mostly hotspotting along the coastline and in the central and northern regions of the country. The table shows that mammals are the class most heavily impacted by oil spills, with 3 species impacted, and this is followed by fish, insects, other animals and reptiles, all with 1 species impacted in each class. Seepage from mining is another subcategory of industrial and military effluents, affecting 4 species, and this heat map shows the overlapping ranges for species with available range data. Examples of sources of seepage from mining as defined by the IUCN Red List include mine tailings and arsenic from gold mining. Hotspotting is predominantly focused along the coastline, between south of Nha Trang, travelling north up to Ha Long. There is also some hotspotting between the cities of Ninh Binh and Hanoi. The table shows that snails are the class most heavily impacted, with 2 species, and this is followed by fish and reptiles, each with 1 species impacted by seepage from mining. "298 species are impacted by agricultural and forestry effluents in Vietnam. This heat map shows the overlapping ranges for those species where range data is available. Agricultural and forestry effluents is made up of the subcategories of nutrient loads, soil erosion, sedimentation, and herbicides and pesticides. As before, the darker areas are where multiple species are impacted. Agricultural and forestry effluents are defined by the IUCN Red List as waterborne pollutants from agricultural, silvicultural, and aquacultural systems. That includes nutrients, toxic chemicals, and/or sediments, including the effects of these pollutants on the site where they are applied. There is much more widespread hotspotting, which may reflect this category of pollutant being more widely prevalent across the country. Nutrient loads is a subcategory of agricultural and forestry effluents affecting 9 species, and this heat map shows the overlapping ranges for those species impacted by nutrient loads in Vietnam, where range data is available. Examples of nutrient loads as defined by the IUCN Red List include nutrient loading from fertiliser runoff, manure from feedlots, and nutrients from aquaculture. There is predominantly hotspotting along the eastern coastline. There is some hotspotting seen inland just south of Saigon, however, most hotspotting is focused along the coastline. This is supported by the table, which indicates that fish are the class most heavily impacted, with 5 species, and this is followed by sharks and rays with 2 species impacted. At the bottom of the table, we find reptiles and snails, each with 1 species impacted by nutrient loads. Soil erosion sedimentation is a subcategory of agricultural and forestry effluents and impacts 257 species. This heat map shows the overlapping ranges for species with available range data impacted by soil erosion and sedimentation in Vietnam. The darker areas are where multiple species are impacted. Examples of soil erosion sedimentation, as defined by the IUCN Red List assessment, include soil erosion from overgrazing, increased runoff, and hence sedimentation due to conversion of forests to agricultural lands. Apart from a clear strip near the coast between the cities of Nha Trang and Ninh Binh, there is considerable hotspotting inland, with a notable darker patch north of Ho Chi Minh. However, the darker hotspotting is focused offshore, and this is supported by the table, which indicates that sea anemones and corals are the class most heavily impacted, with 207 species, and this is followed by fish with 19 species impacted. At the bottom of the table, we find birds with 1 species impacted by soil erosion and sedimentation. Another subcategory of agricultural and forestry effluents is herbicides and pesticides, affecting 20 species in Vietnam, and this heat map shows the overlapping ranges for species with available range data. The darker areas are where multiple species are impacted. Examples of herbicides and pesticides, as defined by the IUCN Red List, include herbicide runoff from orchards. The heat map shows widespread hotspotting across the country, with slightly darker areas found surrounding the cities of Saigon and Hanoi. The table shows that fish are the class most heavily impacted, with 6 species, and this is followed by plants with 5 species impacted. At the bottom of the table, we find sharks and rays, insects, mammals, reptiles, and snails, all with 1 species impacted in each class. "70 species are affected by garbage and solid waste in Vietnam, and this heat map shows the overlapping ranges for species with available range data. Once again, the darker areas are where multiple species are impacted. Garbage and solid waste is defined by the IUCN Red List as rubbish and other solid materials, including those that entangle wildlife. As the heat map shows, hotspotting of this pollution threat is predominantly focused offshore, suggesting it is mainly coastal and/or marine species impacted. The table shows that reptiles and snails are the classes most heavily impacted, with 3 species in each class. At the bottom of the table, we find other animals, which includes springtails with 1 species impacted. Airborne pollutants affect 211 species. This heat map shows the overlapping ranges for species where range data is available, impacted by the higher category of airborne pollutants in Vietnam. The darker areas are where multiple species are impacted. Airborne pollutants are defined by the IUCN Red List as atmospheric pollutants from point and non-point sources. Airborne pollutants include subcategories of acid rain, smog, and ozone. There is hotspotting inland in the central and northern regions of the country. However, most hotspotting is focused along the coastline offshore. This is supported by the table, which shows that sea anemones and corals are the class most heavily impacted, with 207 species, and this is followed by other animals and mammals, each with 2 species impacted. In some of the cases, for a particularly large ranging species, it is hard to associate the threats throughout the species range, and it is not entirely clear where the species are located. So, if we wanted to increase the chances that the species range is representative of threats such as pollution, we can limit our selection of species to only those that have small ranges. So here we demonstrate using the IUCN definition of restricted range, which is species whose entire area of occupancy is up to a maximum of 2,000 kilometres squared. All these areas are so small that the species would be likely endemic to a single country. The orange patches shown on the map are the distribution of restricted range species currently in decline in Vietnam due to pollution. Because the threats to restricted range species are so site-specific, tackling pollution in any of these targeted areas is likely to reverse the risk of extinction for at least one species. The table shows that amphibians are the class in Vietnam with the most restricted range species impacted by pollution, with 4 species. This is followed by insects with 2 species. Bivalves, fish, mammals, reptiles and other animals, which include springtails, all have 1 species impacted in each class. The global analysis allows us to explore the species threatened by pollution by taxonomic group. The graph on the left shows the number of species impacted by pollution divided by class. This graph reveals sea anemones and corals as having the greatest number of species threatened by pollution. This is then followed by bony fish and plants. Crustaceans are shown to have the least number of species impacted by pollution in Vietnam. The graph on the right highlights the proportion of species threatened by pollution in Vietnam, divided up by class. Similarly, this graph shows that sea anemones and corals are the class with the greatest proportion of species threatened by pollution in Vietnam, followed by bony fish and plants, with crustaceans having the lowest proportion of species threatened by pollution. Classes not shown are where there are no species meeting the criteria being threatened or near threatened, as classified by the IUCN Red List, or do not have at least one of the IUCN pollution threat categories increasing their risk of extinction. The global analysis also enables us to pick out specific species threatened by pollution, and this slide highlights a few examples of species in Vietnam. On the top row, we have the endangered giant freshwater whipray and the endangered white-eared night heron. On the second row, there is the loggerhead turtle listed as vulnerable, the endangered Chinese crocodile lizard, the critically endangered tiny flowered Paphiopedilum, and the Irrawaddy dolphin. In the bottom left corner, we see the Emerson's orchid, which is listed as critically endangered. It is possible to find more information about specific species on the IUCN Red List webpage and identify specific pollution threats impacting species. For example, searching the IUCN Red List webpage for the white-eared night heron reveals that this species has an extinction risk of endangered, here shown in bold red. The information also shows that this species is threatened by agricultural and forestry effluents, and in particular soil erosion, sedimentation and herbicides and pesticides. We can see that this results in ecosystem stresses, which leads to ecosystem degradation. To summarise, results were obtained by overlaying range maps of threatened species by pollution and creating heat maps to hotspot areas where multiple species are impacted. The results can be broken down and shown by pollution type, species, and taxonomic group, with more detailed information being provided on the IUCN Red List webpage. Finally, we would like you to think about how this information reflects what you know about pollution in Vietnam. The next 2 slides present a series of questions we would like you to discuss, and I now invite the workshop organiser to pause on each slide to allow you to think about the topics presented. Finally, we thank you for taking the time to listen to this presentation and value your help in discussions. We are also happy to answer any questions, and our contact details can be found on the last slide of this presentation. Thank you for listening.